It's 3-7 maybe? Oh yeah, it was implicit differentiation. I'm sure there was some rough ones in the homework. What bugged you? You can't do all of them. I got that kind of... Was that 3-7 or a review?
3-7.
On number 3-7, on number 1, you're going to have to remember that's the product rule. It makes it a little harder to do. 1. Find dy dx x squared y plus xy squared equals 6. It would help if the board was on. If you're looking at it in the book, you should be thinking product rule. That's what you're going to do. You're going to do the product rule. I'm not going to write out all the steps where I break it into different functions because that's rather time consuming, and part of me thinks it adds to confusion, to be honest with you. Showing every little nitty gritty detail, I think it does add to confusion. But the product rule would say do x squared, then dy dx, and I'm focusing on this piece right here, plus y times 2x. Product rule says 1 times the derivative of the other, plus the other times the derivative of the first. You have any questions on that? I know it seems kind of funny, but I'm following that rule of f of x times g of x. It's f of x, g prime of x, plus g of x, f prime of x. So I'm just following a product rule. That handles x squared y. So now I got to handle x y squared. So plus x, what's the derivative of y squared? 2y dy dx. Plus y squared times the derivative of x, which is 1. That has to equal the derivative of 6, which is 0. That's step 1. Step 2 is to isolate dy dx, which will probably be the easier part for this one. So x squared has a dy dx. It stays on the left. There's this plus x2y dy dx that I'll leave on the left. And I'll shift everything else to the right. I'll have a negative 2xy on the right, and a negative y squared on the right.
So why did we put a dy dx with 2x with the y and 2x?
Because I didn't take the derivative of y there. This piece right here was y times the derivative of x squared. You only write dy dx if you take the derivative of y. You all right with that idea? But only if you take the derivative of something that's not x do you say that you took a derivative. If you take the derivative of x, you don't have to say you did it. It's kind of understood that you do. All right, so I'm going to pull my dy dx. And I could pull a little bit more than that if I wanted to. I might do it later. I'm left with x squared plus 2xy. I should have rearranged that to look better before, but I didn't. And that equals negative 2xy minus y squared. I'll divide out the crap that's attached to it. And that's what I'm left with. I really don't care to modify that anymore. So what you all got to remember is if you take the derivative of y or z or any other thing, you say you took the derivative of that thing. And that's number 1. I guess we move on to what, number 2? What else you want to see?
Not number 2, number 4.
Number 4, big leap. 4 is x squared equals x minus y over x plus y. Now the derivative of x squared is simple. That's 2x. Do you need to say dx dy? You take the derivative of x squared, do you need to say dx dy? No, you don't. It's only when you take the derivative of y that you have to say that. Now, to do this piece, we're going to do the quotient rule. So you're finding the derivative with respect to x of some function f over some function g. And that is g f prime minus f g prime over g squared. That's the quotient rule. That's the rule I'm going to follow when I do the right-hand side. So I'm going to say x plus y. I'm not taking its derivative. So do I have to say dy dx? All right. Now I'm going to take the derivative of this thing. This is f. F of x is x minus y. What's its derivative? What's the derivative of the x? 1 minus dy dx. That's right, because the derivative of y is dy dx. So 1 minus dy dx minus function f, which is x minus y, times the derivative of g, the bottom. What's the derivative of that x? 1 plus dy dx. And it's all sitting over an x plus a y squared. So that's what it looks like in all its ugly glory. So now the task is to solve for dy dx, and that's the fun part. I'm reckoning you're going to foil. Is there an easier way to avoid foiling? No, not that I can see.
I know this probably isn't the source, but if you multiply both by the bottom piece, now we go ahead and pull that out. Does that make sense?
If you multiplied both pieces by x plus y, I wouldn't do it, Maddox. It won't cancel out the x minus y. X plus y can't cancel out an x minus y. Let's see what you got. You got something you want to do the If you multiply the right-hand side, you did what?
I'm talking about.
There's nothing wrong with what you've done, but you FOIL out. You did the FOIL out. It's this line right here.
Yeah, I thought you meant.
No, I'm trying to see if there's a way to avoid the FOIL. Because that's tedious work. I don't even know if my piece of paper is wide enough for it.
Just because sometimes we fool and sometimes we don't.
Yeah, and that's really when you just kind of stare at it and think if there's a way around it. There's not always a way to avoid it. So I'm going to FOIL. There's an x minus an x dy dx plus a y minus a y dy dx. I'm sure there is going to be some stuff that cancels because of this minus sign. So minus, there's an x plus an x dy dx minus a y minus a y dy dx. And it is all sitting over x plus y squared, which I'm not going to mess with. I wasn't talking about the x plus y squared. Maybe I'll mess with it later, but right now I'm not going to. Because the goal is to solve for dy dx, not y. So I really don't care about it. And you might have done yours a little bit differently. I always wrap, but I have an x minus an x. So that's gone. I have a negative x dy dx minus an x dy dx. That's not gone. I have a positive y minus a negative y. That's not gone. I have a negative y dy dx minus another negative dy dx. So those two are gone. I think that's everything that cancels out. Just glancing at it. So 2x equals, there are negative 2x dy dx's. There are positive 2y's. Well, that's what I see. I don't see anything else. Sitting over x plus y squared. Now, I'm going to do something that you and Carolyn did not do. You notice anything, everything is divisible by? What's everything divisible by? 2. The numerator is all divisible by 2. So you can, throw a 2 here, throw a 2 there. And, oh, you did do that? Oh, okay, I just didn't see it. So anyways, I have x equals negative x dy dx plus y sitting over x plus y to the second. Now, your last step was the right step. What they did is they multiplied both sides by x plus y squared. That causes this cancellation right there. And on paper, if I'm showing all my work, I have x squared, x plus y squared x equal to x dy dx plus a y. Now there's two birds to kill here. One is the subtraction of y. If you subtract y, what are you going to divide out? I'm out of paper. I don't have enough room to show two steps. After I subtract y, I'm going to divide by x. So x squared, x plus y all squared times x minus a y. And divide out that x is my dy dx. There's nothing you can do with that. I mean, you could probably FOIL it out x plus y and then multiply it by x. You're not going to see a cancellation, or are you? You are not going to see a cancellation. That's as good as it's going to get. So there's that ugly problem. That was 4. What's the next big leap? 24? Oh, that's one of those find the lines problems. A is tangent and B is normal. (24) is x sines of twice y equals y cosines of twice x. And the point given spam risk. Pi over 4, pi over 2. Why they haven't like modified these phones? Like when you press that little, you swipe left on that thing, what are you thinking in your head? You know, when you ignore a call or something like that. What do you think? What do you think in your head? Anything vulgar any times? No? I have a good sense of humor. I think it should be like F you. That's what it should say. That's me. I'm a little bit vulgar. Makes sense to me. Why aren't they releasing stuff that modifies, customize your phone? All right. So anyways, on to this one. We want to take the derivative of both sides. We want to find dy dx, and it's product rule, kids. Both sides is product rule. Nothing you can do to avoid it. And it's a little bit more than product rule. It's also product rule with a combination of chain rule. So on the left, we'd say x, what's the derivative sign? Cosine twice y. Now, what's in the parentheses is complex. You have to take its derivative as well. What's the derivative of twice y? 2 dy dx. That's the first part of the product rule. I took the original, multiplied by the derivative of the second, plus the second times the derivative of the first. 1. So, look at that. Make sure you make sense of what was done. I know there's a lot going on there. I swear you're just following the rule. Moving on to the next piece. Y, I'm just going to start with the first one. I'm not taking its derivative. Derivative of cosine is negative sine 2x, and there's more than just an x in there, so you got to take the derivative of twice x. 2. Plus, all right, now I'm going to take write the second one down, cosine of 2x, but I'm going to take the derivative of the first. Derivative of y being dy dx. And now I'm going to go through all the fun start of solving for dy dx, but I wonder if I actually have to do that. I'm actually not going to go through the fun process of solving for dy dx, because all I'm going to do is plug numbers into this thing, right? Does it matter when you plug numbers in? Does it? It might be easier to plug the numbers in first. I don't know if that makes any sense to you, but it might be.
Same thing to plugging in right now as if it was more simplified.
Yeah, that's what I'm saying. It doesn't matter when you plug in numbers. Do you have an x value? Do you have a y value? All right, let's see what happens. So x is pi over 4. We're going to multiply that by the cosine of twice y. Y is pi over 2. What's twice y? It's twice pi over 2. No, it's not, Carolyn. We're going to double pi over 2. It's 1. 1 pi. 2 halves makes a what? Whole. All right, and there's still a 2 there. And there's also a dy dx attached to it. Here's sine of 2y again, so sine of pi, 1's understood, equals y, which is pi over 2, times a negative sine of twice an x. So we're going to double pi over 4 and get pi over 2, times a 2, plus the cosine of twice an x. Pi over 4 doubled is pi over 2, dy dx. Now, the reason I did that is because it is quicker for me to do this because I know the unit circle fairly well. What's cosine of pi? Negative what? 1. So this piece is a negative 1. There's a sine of pi. 0. Think about your unit circle, kids. You're at pi. The y value is 0. Sine of pi over 2. 1. Cosine of pi over 2. I'm glad that 0 happened. Why am I glad that 0 happened? I got rid of that dy dx with it too, didn't I? All right, so what do we got left over here? We have a negative 2 pi over 4 dy dx. So negative 2 pi over 4 dy dx, which we can simplify. There's a 0 there. On the right-hand side, it looks like we have a negative 2 pi over 2, doesn't it? I know my handwriting got a little rough, but that's a pi over 2. It came from that guy. So negative 2 pi over 2. So I'll clean that up. That's negative pi over 2 dy dx equal to negative pi. Negatives cancel. Can you divide out the pi and multiply by 2? You know, when you see a fraction, you can approach it from 2 steps. You can divide out the pi's. So you'd have 1/2 dy dx equals 1. And now you can counteract the division of 2. You're doubling it. So dy dx is a 2. It might have made more sense for y'all to solve for dy dx. I don't know. The reason I didn't is because the unit circle. I think it's quicker. I wouldn't have shown near as much work. Y'all are just staring at that clock. It doesn't know anything. Now the goal here was to write the equation of the tangent normal. The 2 you have, what does it represent? Is it slope of the tangent or slope of the normal? That's slope of tangent. So we use a little point slope form. Y minus pi over 2 equals twice x minus pi over 4. Now when you multiply 2 and pi over 4 together, you get pi over 2. So y minus pi over 2 equals twice x minus pi over 2. You have a negative pi over 2 on both sides. They're going with the wind. Did all that work to get y equals 2x. Well, what's the slope of the normal? The opposite reciprocal. So it would be negative 1/2. You won't get as lucky with this one. Y minus pi over 2 equals negative 1/2 of x minus pi over 2. So y minus pi over 2 equals negative 1/2 x plus pi over 4. You're seniors. You're the good seniors. You should understand where that pi over 4 came from. It came from the bottom, twice the 2. Then you're going to add a half. Well, a quarter plus a half is 3/4. So y equals negative 1/2 x plus 3 pi over 4. Remember, that's important in the lenses. Which is a big deal. You know, I wear well, I don't wear glasses anymore. I do it if my contacts are messed up, I do, but I can't see without it. It also has to deal with things like telescopes. Can't stay in the heavens without lenses. Anything that requires magnification or clarification. Anything else I can help you with? Yay, nay, yes? Y'all just sitting there like, why didn't I listen to Milbrath and take pre-calc last year and take dual enrollment this year? What you got, Max? They don't like the dual enrollment teacher this year at all.
It's the same as last year.
Yeah, it's same as last year.
How much?
They're saying she's a little insensitive. How many math teachers you had in your entire life that were not a little bit insensitive?
I didn't even know he was like that though.
It runs with the territory. It really does. Carolyn, your grandmother taught math, and she was a little insensitive, a lot insensitive actually.
I don't think most kids like her.
They didn't, but they were. You could tell a drop off when she left because she was very strict on how you did math. And after she left, it just kind of fell apart. She was a good teacher. She was very strict, caring as could be, but when she was teaching, she was incredibly insensitive. Which is the way math teachers are. What number was that, Maddox? 28. What do you got in store from here? Ooh, something with exponents. X to the 2/3 plus y to the 2/3 is 1. Well, that's actually not too bad. Well, the goal here is to do dy dx and then do d squared y dx. That's just second derivative. I don't think we actually did a second derivative in your notes. So let's just do the first derivative. It's really, really easy. Where's the 2/3 go? Up front. And then you subtract. Subtract 1. It's 2/3 minus 1. Oh, kids. 2 pieces of 3 minus 3 pieces of 3. It's negative 1/3. All right, here, still the same thing. 2/3 goes out front, still y, still negative 1/3, but you took the derivative of y. What do you got to say? dy dx. Now you are going to solve that thing for dy dx. It's 2 steps. Oh, I don't know why I have a 1 there. That's a 0. Derivative of 1 being 0. Subtract that guy. 2/3 y to negative 1/3 dy dx equals a negative 2/3 x to the negative 1/3. And what are you going to divide by? 2/3? Y to the negative 1/3? Perhaps? No? Yes? Maybe? IDGAF? Last one? Well, isolate dy dx, right? You're all worried about these weird exponents. You don't need to be. Just because something looks more intimidating doesn't mean it is. No, it does not. Most people are afraid of big people. Just think about all the big people you meet. They're the nicest people on this planet. It's the small ones that run their mouth. Always. This thing can get cleaned up quite a bit. We're not going to clean up a whole lot. That's gone, right? 2/3 over 2/3. Now, do you want to do the next step using the product rule or the quotient rule? Want to go with product? Well, thankfully, you have a rule about negative exponents. You can move a negative exponent to the numerator. If it's down low, you can move it to the numerator, and the exponent becomes what? If I take y to the negative 1/3 and I shift it up, what happens to its exponent? It becomes positive. There's dy dx. Now we're going to find d squared y dx, which means we take the second derivative. That's exactly what I did. I just took the derivative of the left-hand side. The derivative of dy dx is d squared y dx. Now I got to take the derivative of the right-hand side. And that's going to be the product rule. That's what Maddox wanted. That's what we're doing. Okay? If you don't like it, blame Maddox. All right, so we have the negative x to the negative 1/3. Now I'm going to take the derivative of y to the 1/3 power. 1/3 y negative 2/3, because I subtracted 1 from 1/3. And what else have I got to say? dy dx. Product rule has a plus sign in between them. Y to the 1/3, not taking its derivative, just writing it down. Derivative of the front. A negative times a negative is positive. 1/3 x to the negative 4/3 power. So I took one away from it. All right. Now it's time to do your isolation step. Oh, actually, you're almost done. It's actually really, really easy. Here's your issue. That little guy right there, you're not isolating him. You're isolating d squared y, which is already isolated. The problem is you have a second derivative written in terms of the first, not written in terms of x's and y's. Do you know what dy dx is? What is dy dx? Is that dy dx? So where I see dy dx, what can I replace it with? Maybe that guy right there? So you're left with that ugly, intimidating thing with lots of rational exponents in it. And your job is to clean it up and make it look as pretty as possible. So I guess we'll see what we can do. This is a big string of multiplication right here. That's all it is. It's a big long string of multiplication. Those guys are alike. Negative x times negative x is a positive x. What are you supposed to do with the exponential space? You multiply two things, two like terms, you add them. So negative third plus negative third is a negative 2/3. These guys are alike. They're both y's. We're supposed to add exponential space. It becomes a y to the negative 1/3 power. It's all over 3. Now we got a plus sign here. Is this thing also going to be over a 3? Maybe I shouldn't show that one step. But it is y to the 1/3, x to the negative 4/3, sitting over a 3. Those two fractions have the same denominator, so they can be added, can't they? So add them. You just put them together as a singular one. If you really want to show off your knowledge of math, you can do some factoring here. But it wouldn't look a whole lot better. I'll just see if this makes any sense to y'all. If it does, so be it. If it doesn't, don't worry about it. Does that make any sense? What I did is I factored out an x to the negative 4/3. And factoring is basically like division. When you divide things with exponents, you do subtraction. So a negative 2 minus a negative 4 makes a positive 2 there. I factored out the negative 1/3 power, and that's kind of like division. 1/3 minus negative 1/3 is 2/3. I don't know that anybody actually do that, but yeah, you can. That's a good last step. That's a better last step. I really want to stop there. Unless there's something else urgent. I didn't expect to spend this much time on this. Because I don't think I could even do another one. We at least get half of the homework done. No. You need another one?
What?
You need to do another one?
No, I'm fine. I just worked on the project last night.
Until 11:13. Yeah, I kind of need to be done. Because I want to give y'all something. Study guides, you can have it today. In case you're not here tomorrow. Even if you're not here tomorrow, I'm going to post it. Tomorrow you guys can work on it. I'm probably going to record this for the house. Don't even worry about it. I got issues. So you can watch along if you want. It'd be up to you. But I'm gonna record it for those that are out. I'm gonna go over the sheet. Wouldn't kill you to do it though on your own, or at least look at it. Maybe lay your head on it at night and use osmosis. That doesn't work though, by the way. You can sleep on a math book all you want. All you're gonna do is have a crick in your neck when you wake up.